students. I welcome you all to Brihan Mumbai Municipal Corporation Education Department, Online Education for English Medium. We are conducting subject Science and Technology Part 1. And the topic which we are going to discuss is space mission. Yeah, sorry for some technical issues were there. Yeah, students, so we are conducting this online session for Science and Technology Part 1. The topic which we are going to learn is space mission. Subtopic today we are going to learn is satellite launch vehicle. What are that? My name is Mrs. Bushra Ahmed and our Children Nodal Officer name is Mrs. Rushani Kalamni. Students, we are learning lesson number 10, space mission. In previous two sessions, we have learned what is space mission, need and importance of space mission. Again, what are the objectives, two objectives of a space mission. Then in last session, we have seen different orbits of satellite, artificial satellite, right? So today in this session, I'll do a speed recap of few points which I have taught you in the last session, and then we'll continue to the launching vehicle. So student, in the last session, we have seen three orbits. Number first one was high Earth orbit, second one was medium Earth orbit, and third one was low Earth orbit. Depending on the height of the satellites orbits above the Earth, they are classified into in these three types of orbit. Okay, at which height? See, number first one, the high Earth orbit. In this, student, the satellite are launched at how much height? More than 35,780 kilometers. If the height of the satellite orbits above the Earth's surface is greater than or equal to 35,780 kilometers, then that orbit is called as high Earth orbit. Again, student, the satellite revolving in an orbit that is 35,780 kilometers above the Earth's surface will take about 24 hours to complete one revolution. How much time it will take, students? It will take 24 hours to complete one revolution. We know that Earth also takes almost 24 hours for one revolution, right? You know this one. If the satellite is revolving in an orbit parallel to the equator, the time of the revolution for the Earth's orbit itself and that for the satellite to revolve around the Earth being the same. If it is revolving parallel to the Earth, this in detail I have explained you yesterday. So for that purpose only, I'm just revising it speedily so that you can remember all the points which I have taught you yesterday. See, as it is revolving parallel with the same period to the equator, hence that satellite will be what? When we are seeing that satellite from the Earth, so we see that it is stationary. Why? Because the period of revolution of Earth and that of that satellite is same, hence it appears to be a stationary. Example, for a passenger in one vehicle, another vehicle moving parallel to him with equal speed appears to be stationary. This example we have seen yesterday. If two vehicles are going with the same speed, and so what a person is sitting in a one vehicle, what he will see that the other vehicle is stationary. Why? Because they both are moving with the same speed. This is what happens here also. These satellites are therefore called as geosynchronous satellite. They are called as what, student? Geosynchronous satellite. Why? Because Their period of revolution is 24 hours and they are revolving in an orbit which is parallel to the equator. Hence, they are seen to be stationary from the Earth. Hence, they are known as geosynchronous satellites. Since these satellites are stationary with reference to the Earth, they can observe a specific portion of the Earth continuously, right? As they seems to be stationary, so they will be continuously focusing on or referencing to a specific portion of the Earth. Therefore, they are used in application like meteorology. Meteorology means for weathering, right? For weather forecasting, this all purpose, and for carrying signals for telephones, televisions, radio, etc. This is how what we have learned, that is high Earth orbit. Now we are going to learn about medium Earth orbit. See students, height above the Earth's surface is 2000 kilometer to 35,780 kilometer. That orbit is known as medium Earth orbit. If the Earth of the satellite orbits above the Earth's surface is between 2,000 and 35,780 kilometers, the orbits are called medium Earth orbits. Geostationary satellite orbit above the equator, these are therefore not useful in the study of polar regions. They are not. Now see students, hence these are focusing on the equator part. It is revolving parallel to the equator. So how it will be focusing on the polar regions? No, right? So for this purpose, what the shape of the orbit should be there? It should be the elliptical, so that only we can focus on the polar region of the Earth. For this purpose, elliptical medium orbit, Earth orbit, passing over the polar regions are used. These orbits are called polar orbits. In these orbits, the satellite completes one revolution in 2 to 24 hours. Some of the satellite revolves in circular orbit at a height of around 20 to 200 kilometers above the Earth's surface. Global position satellite revolves in such orbits. Now students, we are going to learn about low Earth orbit. Now see, height above the Earth's surface 180 kilometer to 2000 kilometer. If the height of the satellite orbits above the Earth's surface is between 180 kilometers to 2000 kilometer, the orbits are called low Earth orbits. See students, whenever the height of the orbits is between 180 kilometers to 2000 kilometers above the Earth's surface, that orbit is known as what? That orbit is known as low Earth orbits. Now see students, height above the Earth's surface is, if the satellite used for the scientific experiment and atmospheric study revolves in low Earth orbit. See students, the satellites which are revolving in low Earth orbit, they are used for which purpose, students? They are used for scientific experiments and for the atmospheric studies. So whenever it is, sometimes it is asked in multiple type question also, that which satellites are for which purpose these satellites are launched in low Earth orbit. So the main one is the main reason is the satellites which are used for scientific experiment and for atmospheric studies, they all revolve in where? In a low Earth orbit. See here, all three orbits I have shown in a one figure. Can you see this here? The circular one, it is high Earth orbit. Again, see the elliptical one, it is MEO, that is middle Earth orbit. And again the circular one, that is, see, MEO might be circular also and the elliptical also. And low Earth orbit, it is always circular. See, low Earth orbit and high Earth orbit are always circular, while MEO, that is medium Earth orbit, it is in circular shape also and might be in the elliptical shape also. Now, do you know that a group of students from COEP, College of Engineering Pune, made a small satellite and sent it to the space through ISRO in 2016. The name of the satellite is what, students? It is Swayam, and its weight is just around 1 kg. How much is the weight of that satellite? It's just around 1 kg. It is orbiting the Earth at a height of 515 kilometers, that is 515 kilometers. The main objective of the satellite was to provide point-to-point messaging service using a special method. Now, see, students, this all we have seen till here last lectures. Today, we are going to see about satellite launch vehicles. What is satellite launch vehicles? See, satellite launch vehicles are used to place the satellite in the specific orbit. Now, see, it is not like that. If you want to put a satellite, so we just ignite the satellite here and satellite will get launched into the orbit. So we required a vehicle, a launcher vehicle, to place the satellite in its specific orbits. The functioning of the satellite launch vehicle is based on the Newton's third law of motion. See, the functioning of this launcher vehicle, it is based on which law? Newton's third law of motion. We all know what is Newton's third law of motion. Newton's third law of motion is nothing but every action has equal and opposite reaction, right? So on this law, Newton's third law of motion, the function of the satellite launcher vehicle is based. The launch vehicle use specific type of fuel. They use what, students? They use a specific type of fuel. The gas produced due to the combustion of the fuel expand. Now see, the gas which is produced when the fuel is when combustion of the fuel takes place, it's expand due to its high temperature and it expel forcefully through the nozzle at rear side of the launcher vehicle. See, whenever it is seen, it is shown in the front page of your textbook also. See, there is a launching of a satellite is taking place. So can you see in the rear side, forcefully we see that forcefully some gases are coming out, and this is due to a gas which is produced due to the combustion of the fuel, which expand due to what? Due to the high temperature when it is ignited, and it expels forcefully through the nozzle at the rear side of the launch vehicle. As a reaction of this, see, as a reaction of this, a thrust acts on the vehicle. What acts, student? Thrust. And this thrust will, what it will do? It will up, right? Which drives the vehicle high in the space. What it does? It drives the vehicle high in the space. The structure of the launch vehicle is decided by the weight of the satellite and the type of the satellite orbit. See, students, the structure of the launcher vehicle, it is based on what? It is based on the two things. Number one is the weight of the satellite, and number second is the type of the satellite orbit, in which orbit it is supposed to be placed. Might be in the low Earth orbit, medium Earth orbit, or high Earth orbit. In which satellite it is supposed to place, and what is the weight of the satellite. In this two things, the structure of the launch vehicle is based. The fuel of the satellite also depends on this factor. Now see, the fuel which we are using in the vehicle, it also depends on the same factor. The fuel formed a major portion of the total weight of the launch vehicle. See, the huge amount of fuel is required for the launcher to launch the satellite. Hence, it consists of the major portion of the total weight of a launch vehicle. Thus, the vehicle has to carry a large weight of the fuel with it. For that reason, students, what? This vehicle has to carry large weight of fuel with it. So might sometimes it got very disadvantage for the launcher vehicle that he has to carry so much weight of the fuel with it. For that, students, there comes into to an existence of the stages. Now, what are that stages? To overcome this problem, students, launch vehicles will with more than one stages are used. For this, as they have to carry a high amount of large amount of fuel with it for the launching purpose. So to overcome this problem, launch vehicles, they are carrying what more than one stages are used. Due to this, the weight of the vehicle can be reduced step by step. It is reduced step by step after its launching, when it is get launched. For example, consider a launch vehicle having two stages. Now consider it is having which stage? Two stage. For launching the vehicle, the fuel and the engine in the first stage is used. Now see, if consider there is one launcher vehicle which is launching the satellite. So for launching this satellite, consider for launching the vehicle, the fuel and the engine in the first stage are used. First stage, in the fuel which is present and the engine which is present in the first stage, it is used for the launching of the vehicle. This impart a specific velocity to the vehicle and takes it to a certain height. So when the engine and the fuel which is used up in the first stage, what it will do, it will impart some specific velocity to the vehicle and it takes it to the certain height. Sure, it will take it to the certain height. Once the fuel in the first stage is exhausted, now see, if in the first stage the fuel is being exhausted, the empty fuel tanks and the engine are detached from the main body of the vehicle and fall either into a sea or on a populated land. Okay. Once, see students, as a fuel in the first stage is exhausted, at that time what students, the empty fuel tank and the engines are detached from the main body. What happens when they are used? They are detached from the main body. See, sometimes we hear a large sound of something is thrown on a surface, right? So this is where this detached body, this engine which is been fall on a unpopulated area or into a sea. As the fuel in the first stage is exhausted, the fuel in the second stage is ignited. Now see student, as the fuel in the first stage, the fuel is get exhausted, then the fuel of the second stage will get ignited. However, the vehicle now contains only, that is the second stage, the weight now will reduce and the vehicle can move with a higher speed. Now see students, as in the first stage, if the fuel is finished, the work of the engine is finished, it imparts some specific velocity to a satellite. Now see, after that the second stage is ignited and that part, the empty shells of a fuel tank and engine is detached. So obviously its weights will get reduced, right? It will get reduced and now this launcher vehicle will move with a higher speed. Yeah, see, if the weight will be reduced, it will move with a higher speed. Almost all vehicles are made up of either two or more stages. See students, all the launcher vehicles, they are made up of two or more stages. As an example, the structure of Polar Satellite Launch Vehicle, that is PSLV, developed by ISRO of India. See, in ISRO, the launcher vehicle which is been designed, that is nothing but PSLV, that is Polar Satellite Launch Vehicle. The launch vehicles are very costly. They are very costly because they can be used only once. They can be used only once. For this purpose, they are very costly. USA has therefore developed space shuttle. See the figure of the space shuttle I'll show you. USA has therefore developed a space shuttle which return to the earth except for the fuel tanks and can be reused in multiple times. See, for that purpose, students, USA, what he has done, he has developed one space shuttle. As this launcher vehicles were used only for one time, it becomes very costly. For that purpose, they have designed a space shuttle which return to the earth except for the fuel tanks and can be reused for multiple launches. Okay. See, students, this is a structure of PSLV made by ISRO. Can you see the lower one? You see multiple rocket type structures are there that are nothing but student engine using solid fuels which produce the initial thrust. See the lower part, this lower part. This lower part is nothing but engine using solid fuels which provides the initial thrust. First stage using solid fuel. See, this is one is the first stage, which consists of which fuel? Solid fuel. See, the upper one is the second stage using which? Liquid fuel. Third stage, whenever the third stage is required, it is by using which fuel? Solid fuel. And the fourth stage, if fourth stage is also required, that is used for liquid fuel. And this is, can you see the topmost part, this topmost part, the conical part? This is the place where the satellite is been kept, place for satellite. This is for place for a satellite. Okay, so this is the structure of PSLV made by ISRO, launcher vehicle. This is. Now this space shuttle, I have told you, I'll show you the space shuttle also. See, can you see a figure exactly on the left hand side? This is nothing but a space shuttle, students. This is space shuttle. When space shuttle is ignited, when it ignited, it boosts some speed up. See here, when there's a separation of the first stage. So there was a separation of the booster rocket, the rocket which are used for the booster purpose. After that, student, separation of these two rockets, what is separated? Separation of fuel tank. When tank becomes empty, it is also gets separated. And this space shuttle, what it do? It's just space shuttle now is gone to an orbit where the satellite is about to revolve, and now this space shuttle opens up and the satellite which is inside gets start or revolving around the orbit. And after that, after when satellite is launched in its orbit, and space shuttle again comes return back to the earth. So after just skipping the satellite orbit, revolving around the orbit, this space shuttle again comes back to the earth, and for hence this space shuttle is used for multiple times. Okay, multiple times it is used. But our PSLV we are using, it can be used only for one time, but space shuttles are used for multiple times for launching purpose. Always remember the rocket, a type of firecrackers used in Diwali, is also a sort of launcher. It is also a sort of launcher. You know, in Diwali, you are firing the firecrackers, the rockets, right? It is also a type of launcher. In this rocket, the fuel is ignited using a fuse, and the rocket is projected into the sky just like a satellite launcher, same as a satellite launcher. When you're igniting the fuel, right, the fuel is what it is doing, it is creating, expanding the gas. The gas forcefully comes to the lower part, to the nozzle part, and it gives thrust to that rocket to move to the upper part. Okay, for that purpose this rocket are also the sort of launcher. Similarly, if a balloon is blown, see, when you are blowing a balloon, and if you release it with one end, what you see, that balloon goes up. Why it goes up? Because the air in the balloon is forcefully ejected and the balloon is pushed in the opposite direction. As it is forcefully ejected from one side, so it gives what? It is pushed through that balloon to the opposite side. be explained using Newton's third law of motion, right? Because according to Newton's third law of motion, we know that every action has equal and opposite reaction. So always remember this point. Now, space mission away from the Earth. Space mission away from, what are the space mission will take place away from the Earth? Now see, as we have seen above, artificial satellites are being used for making our life more and more enriched. Yeah, we have seen need and importance of the artificial satellites. Much more importance are there, right? For communication purpose, for meteorological purpose, for agricultural purpose, for getting the alarm of the natural calamities which are going to happen. These all things we have seen need and importance of artificial missions, right? Space mission. So students, however, in the previous standard, we have learned about how the telescopes aboard artificial satellites are used to gather information about the various objects in the universe. We have seen that telescopes were also used for gathering the information around us, right? Around the earth, around in the universe, the objects which are present in the universe. Similarly, some space missions are used to gain further knowledge about the universe. Similarly, students, some space missions has been taken up to gain what further knowledge about the universe. In this mission, spacecraft are sent to nearby objects in the solar system to observe them more carefully, more closely. So for this purpose, this spacecraft has been sent to that object in the solar system to observe them very closely and to examine it and for the further research work. Okay, new information has been obtained from such missions and it is helping us to understand the creation and evolution of our solar system. See students, new information has been obtained. New what? New information has been obtained from such missions and it is helping us to understand the what? To understand the creation and evolution of our solar system. For such mission, the spacecraft must escape the Earth's gravitation force to travel into the outer space. For this purpose, now see if he has to go to the outer space, right? So he has to come across he has to travel out of this space. So he has to escape the Earth's gravitational force. So what for that purpose, he should have a much more velocity so that he can escape the Earth's gravitational force. Otherwise, Earth's gravitational force will not allow that object to go outside. Now see student, to achieve this, the initial velocity of moving object must be greater than the escape velocity of the Earth, as we have learned in the chapter of gravitation. In gravity, students, what we have learned? We have learned about the escape velocity, right? Escape velocity of the Earth. So for that purpose, student, the initial velocity of this moving object, of this spacecraft, must be what? It must be always and always greater than the escape velocity. Okay, now see, escape velocity on a planet can be obtained using a formula. Now see, we have to see which formula it is there from which this scientist has calculated what is the escape velocity. See, in yesterday's lecture, I have shown you how to calculate what is the formula to calculate the critical velocity, the velocity in which the satellite can move in an Earth's orbit. Okay, now there is again one formula due to which we can calculate what should be the escape velocity, and by that we can provide that much velocity to a spacecraft, and then only it will can overcome with the gravitational force of the Earth, and can move to the outer space and can go to the place where we are supposed to do the observation purpose in a solar system. See students, can you see here a photograph? See a launcher vehicle here, a rocket is see here spacecraft is getting launched here due to the help of launcher vehicle, right? So the minimum velocity of a spacecraft should be 11.2 kilometer per second. Initial velocity should be this one. Minimum velocity should be. Now how we have calculated this, students? See here. Escape velocity of a planet VESC equals to under root of 2 gm upon r. Now here students, this capital G stand for gravitational constant. How much is the gravitational constant? It is 6.67 into 10 raised to minus 11 Newton meter square per kg square. This value always you have to remember. In numericals also it is asked, if it is asked to calculate, so we have to remember these values. Capital M is the mass of the planet. Mass of the planet, which planet? Earth. So how much is the mass of the Earth planet? It is 6 into 10 raised to 24 kg. Mass of the planet is 6 into 10 raised to 24 kg. Capital R is the radius of the planet. And how much is the radius of the Earth planet? It is 6.4 into 10 raised to 6 meter. This is how much the radius of the Earth planet is. When we will substitute all these values in the above formula, what we will see? We will see that now see we have put all the values under root of 2 into 6.67 into 10 raised to minus 11 value of G gravitational constant. Then I have put the value of mass of planet, that is 6 into 10 raised to 24 divided by capital R, that is radius of the planet. How much it is? 6.4 into 10 raised to 6 meter. By doing the calculation, what answer I have got? It is 11.18. 188 is greater than 5, so directly what we can put? 11.2. 1 will get transferred into 2. This is the terms of mathematics, right? So 11.2 into 10 raised to 3 meter per second, or it can be 11.2 kilometer per second. If this much is the velocity of the spacecraft, it can overcome to the gravitational force of the Earth and can move into a space. The spacecraft to escape the Earth's gravitational force, to travel to the outer space, it must have minimum velocity of 11.2 kilometers per second. Okay, students, so I hope this all you have understood today. What are the things I have taught you today, students? I have taught you about the launcher vehicle, right? The launcher vehicle, on which law it is being used? Newton's second law of motion, right? So, or Newton's third law? Newton's third law of motion, right? So, again, what we have seen in this, ISRO has what? ISRO has made a PSLV, that is Polar Satellite Launch Vehicle, which is developed by ISRO to launch a satellite into an orbit, while USA has made a space shuttle which launched the vehicle into the orbit and come back to the Earth, and it is used for multiple purpose. Again, see here how the satellite has been launched into an orbit using space shuttle that we have seen, right? So this is all the things which we have learned today. Again, we have learned how much should be the escape velocity of that launcher vehicle so that it should be placed into an orbit. So thank you for watching my session, student. Thank you so much. Hello, ma'am. Ma'am, am I audible to you? Hello, ma'am. Am I audible to you? Ma'am? Hello? Ma'am? Ma'am, am I audible to you? I have winded up my lecture. Hello, students? She has muted students also, right?